Okay, in this video we are going to talk about solving trig equations that look something like sine of x equals cosine of 246 degrees and things like that. So it's kind of a unique type of equation, but I really like it because it makes you practice a lot of really important skills in trig. Let's take a look at the main things that you're going to use. So the first one you're definitely going to use on a lot of these, though not a lot of my examples here, are principal coterminal angles. So those are the angles between 0 and 360 or 0 and 2 pi within the first revolution. You really just want to work with those. You never want to work with an angle that's larger than one full revolution. So that's your first step in the event that the angle is too big. The next thing you're going to use a lot of are cofunction identities. Specifically here, we're going to use either sine of x is cosine of pi over 2 minus x, or cosine of x is sine of pi over 2 minus x. But actually in this video I did everything in degrees because it's a little easier to do the arithmetic stuff. So in our case, we'll really be looking at sine is cosine of 90 minus x, cosine is sine of 90 minus x. Another thing that we're going to make kind of extensive use of is ASTC. So that's sort of a mnemonic that tells you where each trig function is positive. So I usually draw a coordinate grid and just label it up. It goes starting in quadrant 1, you go counterclockwise. All of them are positive, sine and cosecant are positive, tangent and cotangent are positive, cosine and secant are positive. So this is telling you which of like the original trig functions are positive, and then their reciprocals are obviously positive if they are positive, and then everything else is negative. The other thing that's related to this will be reference angles. Reference angles are the tiny angle that is formed with the closest part of the x-axis. I'm saying tiny, it's the acute angle that's formed with the closest part of the x-axis. So in the first quadrant, that's just the angle is its reference angle. In the second, it's 180 minus the angle. In the third, it's the angle minus 180. And in the fourth, it's 2 pi minus the angle. I think or 360. I think I'm bouncing back and forth between degrees and radians. I apologize. And then the final thing that we're going to make kind of extensive use of is the unit circle. I love the unit circle. It tells you how to solve a lot of problems. Let's get into an example and see some of these things at work. So our first example, we're going to solve sine of x equals sine of 573 degrees. First thing that I notice is 573 degrees is bigger than 360, and because of that, we want to find the principal coterminal angle. So we're going to rewrite this as the sine of the principal coterminal. So I'm just going to subtract off the 360. There's a whole process you can go through to find principal coterminal angles. You divide by 360, you take the floor or the greatest integer of the result, and then you subtract. But it's usually easier to actually just think to yourself, what multiple of 360 is closest to this number. In this case, the multiple of 360 closest to 573 but less is just 360. So I'm subtracting. Principal coterminal is 213. That's the angle we really want to deal with. All right, at this point, we're going to think about the unit circle and how it can help us, right? So we're thinking unit circle. So I'm going to draw a unit circle. And I'm going to put 213 degrees on it. So it's in quadrant 3. Now, on the unit circle, sine is the y-coordinate, right? That's one of the key features. Sine is the y-coordinate, cosine is the x-coordinate. The quadrantals are amazing. You should just memorize the unit circle and kind of everything about it. If the y-coordinate is sine, and we are looking for where sine of x is equal to sine of 213, all I need to do is draw a horizontal line here. And where that line intersects the circle, the angles corresponding to that will be our solutions. So another solution is here. Now, how do I find that? I'm going to look for this reference angle, right? I'm a little over 180, so to find the reference angle, I will do the angle minus 180. So my reference angle is going to be 213 minus 180 is 33. It's 33 degrees. Now, how do I put this in quadrant 4? So in quadrant 4, if I know the reference angle, to find the angle, I'm going to do 360 minus the reference angle. So 360 minus 33 is 327. So the two principal angles that are solutions to this equation are 213 degrees and 327 degrees. But we need to generalize and find all values of x. So my first solution will look like 213 plus 360 times n. And my second solution will look like 327 plus 360 times n. And then I need to specify that n is an element of the integers. So there we go. So that's how we would solve this. This is if the angle is bigger than 360. There's a little more that we need to kind of talk about, so let's look at another example. This one will be with cosine. It'll be a little, I think, maybe easier. And then we'll also take a look at a third problem, which is a little more in depth. So you might want to skip this one if you know what you're doing. If not, like let's take a look. So this one, I just gave you a principal coterminal angle or a principal angle. So 98 degrees is between 0 and 360. I'm just going to start off by drawing the unit circle with 98 degrees. Cosine is the x coordinate, so we know that. So a vertical line in this case, where that vertical line intersects the unit circle, those are our two solutions. Now what I'm going to do is find a reference angle. So in quadrant 2, the reference angle is 180 minus the angle. So I'm going to do 180 minus 98 to get 82. So 82 is the reference angle. Now what I need is an angle in quadrant 3 that has an 82 degree reference angle. In quadrant 3, if you know the reference angle, the actual angle is 180 plus the reference angle. So we'll do 180 plus the reference angle, and that should give us 262. Okay, so now we want to write our answers. Our two principal solutions are 98 degrees and 262 degrees, but we have to generalize. So I'm just going to throw that up there. So we get 98 degrees plus 360n, 262 degrees plus 360n, and then n is an element of the integers. All right, I'm going to do one last problem here. It's a little more involved, but it's really not that bad. And it kind of just feels like a slightly different problem, but let's take a look. So we want to solve sine of x equals cosine of 230 degrees. So this is essentially the problem that was promised in the intro to the video, except not the problem that was in the intro because I didn't even think about that. All right, so step one is when you look at this, if you don't have the exact same trig function on the left and right hand side of your equation, you're going to struggle to solve it. So we need the same function. So to do that, we are going to convert cosine of 230 degrees somehow into sine of something. Just let's do it. So I'm going to start with the unit circle, and I'm going to graph 230. So we have our unit circle, ASTC. 230 is here. It's in the third quadrant. So I need a reference angle. Now my reference angle will be, because we're in the third quadrant, 230 minus 180, which is 50. Another thing that we need to note at this point is since we're in the third quadrant, we know cosine is negative. So what we can do with that information is we can say that the cosine of 230 is equal to, so it's not that the cosine of 230 is equal to the cosine of 50. That's not the case because cosine of 230 is negative, cosine of 50 is positive. Cosine of 230 is the negative of the cosine of 50. That's a big deal. That's usually where solutions go wrong when people are doing these on their own. So that's good, except we still don't have the same function, right? We just have negative cosine of 50 now. Let's change that into a sine by using a cofunction identity. So for a cofunction identity, I'm going to say that the negative of the cosine of 50 is going to be equal to, when you use a cofunction identity, you never change whether something is positive or negative. So if there's a negative in front of it to begin with, there'll be a negative in front of it after you cofunction. The same is true if there's a positive, it'll still be a positive in front. It doesn't mean that the value overall is positive or negative. Like negative cosine of 50 is a negative number, but we're going to put a negative here. And then it should be the sine of 90 minus 50, so the sine of 40, right? So that's 90 minus 50. That's our cofunction identity. But if you look at it, these are still not the same function, right? We have now sine of x is equal to the negative of the sine of 40. Negative sine of 40 or negative sine is not the same as sine. So we got to do a little more work. These are still not the same. So we're going to unit circle this again to help us out. So we have the same thing, ASTC. Maybe draw multiple figures as you're solving. It's up to you. We are looking at negative sine of 40. Now there's two pieces of information that we have here. The first one is that 40 degrees is definitely the reference angle that we want to work with. But there's four angles that have a 40 degree reference angle between 0 and 360. We need to know which to use. That comes from the fact that there's a negative here. The fact that there's a negative here tells us what quadrant we're going to be in. We just think to ourselves, which quadrants have negative signs? Well, it's not quadrant 1 because everything's positive. It's not quadrant 2 because sine is positive. It's quadrants 3 and 4. So if we write the 40 degree angles in quadrants 3 and 4, those will be basically our answers, but then we'll have to generalize. So these are our two kind of angles. So we'll do 180 plus the reference angle in quadrant 3. So 220 is one of our principal solutions. And then we'll do 360 minus 40, and that'll give us our other principal solution. But then we have to write it up, right? So our first solution is going, well, not our first solution. Now we know that sine of x is equal to the sine of 220. Definitely, right? Based on the original, sine of x equals cosine of 230 is equivalent to sine of x equals sine of 220. That's one equation. The other equation is that sine of x equals sine of 320. But remember, we're solving for x. We're not solving for like sine of x. So you got to get the x out of there. So what we're going to do is just equate the arguments here. So we're going to say for the first one that x is 220 degrees plus 360 degrees times n. And for the second one, x is 320 degrees plus 360 degrees times n. And then finally, n is an element of the integers. All right, so that's 3 examples of how you can do this. I would say the third one is like, that's the goal. You want to be able to solve problems like the third one. The first 2 are kind of like a warm-up. I hope this was helpful, and good luck.